A team of scientists estimated the thickness of Europa's icy crust with the help of state-of-the-art simulations, a press statement reveals. Scientists have long considered Jupiter's moon Europa as one of the leading candidates for discovering microbial alien life in our solar system. This is because it is believed to contain a vast saltwater ocean under its thick icy crust. Knowing the thickness of that crust could, therefore, aid future missions designed to study the habitability of the icy world. Estimating the thickness of Europa's icy crust. The scientists, who published their findings in a new paper in the journal Science Advances, estimated Europa's icy crust to be at least 20 kilometers, approximately 12 miles, thick. In order to attain that number, they ran simulations based on multi-ring impact structures observed on Europa's surface, called Tyre and Kalanish. These structures feature multiple circular valleys between faults, also known as concentric ring graben. These span more than 30 kilometers, 18.6 miles, and they could provide vital clues regarding the composition of Europa's icy outer shell. Shigeru Wakita and colleagues used images captured by Galileo of Tyre and Kalanish to model potential impacts and other factors that may have led to the formation of these concentric ring graben. They used a shock physics code developed to simulate planetary impacts, allowing them to model impacts of different sizes on the surface of Europa. They ran their model in scenarios with different ice shell thicknesses and different thermal gradients. Ultimately, these simulations allowed them to make an educated estimate of the thickness of Europa's ice. The research team found that the impacts formed graben-like features only when the Moon's ice shell was at least 20 kilometers thick. The icy shell also had to be composed of a 6–8 kilometer heat-conducting ice layer on top of a warmer, convecting ice layer above its liquid ocean. Searching for extraterrestrial life on Europa. The new results could help to reveal whether Europa contains alien life or not. As the scientists explained in their paper, the constraints on Europa's ice shell structure resulting from this work are directly relevant to our understanding of the potential habitability of Europa. More than 20 years ago, NASA's Galileo mission analyzed Europa's icy surface and found evidence of an abundance of liquid saltwater lying beneath the Moon's icy exterior. Due to those findings, scientists believe Europa is possibly the strongest candidate for finding alien life in our solar system. Some recent findings have suggested we should temper our expectations when it comes to finding life on Europa. A recent analysis of Europa's evolution suggests it didn't have a core for much of its existence, hindering the chances it could harbor extraterrestrial life. Another study this year suggests that Europa's rocky crust resists seismic fracturing. This would prevent the geochemical reactions required to create life from taking place. Still, we won't know for certain until we extensively investigate Europa's massive ocean. Several future missions, including NASA's Europa Clipper, scheduled to launch in October, aim to investigate the potential habitability of Europa. It is expected to arrive at Jupiter in 2030.